Welcome to the Crazy Hat Chemist. So here we go, the second video on equilibrium and reaction rates. Bam! So chemical reaction progress. What I want you to do is carefully look at this graph. On the y-axis we have the potential energy, and on the x-axis we have time. Okay, I'm going to point out some key features of this graphic. Here we go. Bam! Reactants are here on the left-hand side here, and I've circled that. Okay, then we're going to go to products. Products are on the right-hand side, just like all reactions are set up. Okay, this line right over here, the bottom of where the reactants are to the top of the peak of the graph, is called the activation energy, and that is E sub A. This is the activation energy for the forward reaction. This is how much energy it costs to overcome from the reactants to go to the products. It's kind of like rolling a ball up a hill. You have to roll the ball all the way up to the top of the hill, and once you've inputted that energy up to the top of the hill, then the reaction proceeds forward. Okay? And then this is the activation energy with a catalyst. So we're going to talk about catalysts later on, but you should see that the dashed line is the reaction with the catalyst. You notice that the reactants and the products are at the same positions that they are with an uncatalyzed reaction. But a catalyzed reaction is lower. It has a lower activation energy barrier. Therefore, it costs less energy to go from reactants to products with a catalyst. Okay, this is the activation energy of the reverse reaction. So remember, equilibrium reactions can be approached from either the reactant side or the product side. So if you approach this from the product side, then you should see that going from products to reactants actually is less energy than going from reactants to products, because the activation energy for the reverse is shorter than the activation energy for the forward reaction. Okay, this is the activated complex. This is the peak of the graph. This is the most strained portion of a molecule right here. The most unusual and strained portion of the molecule. It has the highest energy at the activated complex at the top of the peak. Okay. The difference between the reactants and the products, if the products are greater in energy than the reactants, then that's called delta H naught for the reaction, and that's going to be positive. Okay, and this is the enthalpy change of the reaction. And if the number is positive, then this is an endothermic reaction. Okay, we're going to change this graph just slightly, and let's say that the products are actually lower in energy than the reactants. Again, the difference between the reactants and the products is going to be the delta H naught for the reaction, which is the change in enthalpy for the reaction. But when the products are lower than the reactants, then you have a negative value for the delta H naught for the reaction, and that is going to lead to a exothermic reaction. Okay, hopefully that graphic made sense for you. All right, I'm the Crazy Hat Chemist. That was the second video on equilibrium and reaction rates. I'll see you next time. Bye.